Okay, so this is Geometry Week 2. We had Geometry Week 1 last week, and today we're basically gonna learn about coordinate grid transformations, and here is what we gotta learn this week. Okay, here are some definitions about the vocabularies we're gonna talk about. And quadrants, as you know, it's like coordinate grid has 4 quadrants. It's separated into 4 parts based on the x-axis and the y-axis. So the quadrants go by counterclockwise, which starts from, let me draw basic coordinate is like this, and this is quadrant 1, this is quadrant 2, and this is quadrant 3. I don't know, can't write so well on this. And this is quadrant 4. So it goes like a counterclockwise. And x-intercept is the value of x when at the point where the graph intersects the y-axis, which is like the graph looks like this, and basically the x-intercept is like, wait, I think, yeah, the x-intercept is basically this point where it touched, and y-intercept it's the same, but it's y-axis. And the slope of the line, we're going to learn about the slope next slide. And slope is basically how steep the line is. As you can see, the line is tilted. When the line is horizontal, it has no slope. And when the line is vertical, the slope is undefined. Okay, so when the line is vertical, the slope is undefined because it cannot have because basically the slope is rise over run. So basically if the rise is 3 units and the run is 2 units, it's rise over run. But as you can see, this line, there is no run. Basically the line is not going anywhere horizontally, so there is no run over this case, so the run would be 0, and if the denominator is 0, it would be undefined. Did you get that? Or if you didn't understand anything, you can let us know. You can type in the chat or okay, then we're gonna go to the next slide. Okay, so we're gonna learn about writing linear equations first. And do you know any of these 3 equations? If you know, you can write it in the chat, like being which one, the first one is what, or like second one's what, or if you don't know, we can just get started learning. I can't tell if he's typing or not. Okay, so the first one is slope-intercept form, and the second one is a standard form, and the third one is point-slope form. Okay, slope-intercept form is basically a very basic formula we can use when we're writing a linear equation. Okay, we're gonna talk about these formulas, don't worry. So basically y equals mx plus b. You know, y and x are the variables on the line, on the coordinates, and the equation of a straight line in the form y equals mx plus b, where m is the slope of the line and b is its y-intercept. Like we talked about, when we're on a coordinate, we have a line, and m is the slope. In this case here, m is the slope of the line, basically how steep this line is, and b is y-intercept, which is this point where it intersects the y axis. So basically you plug in the numbers for if it's given like a value. Okay, let me show the graph too, because I do have a graph here. So as you can see, the line over here is y equals negative 3/4 of x plus 2. So the slope here in this case is, what did I do? Negative 3/4 of x. And basically you can see that the line went down 3 and went right 4. So basically going down is negative, so this is why you have a negative sign here, and going right is positive, so it's negative 3/4. And plus 2, you see that the 2 is here. So if the y-intercept is anywhere under 0, it would be negative here. Did you get that? Do you understand how it worked? Let us know if you don't understand anything. Okay, I'm gonna go on the next slide. Okay, here are some practice problems. I don't know if you can solve them, but basically we have to turn these equations into the slope-intercept form, which is the y equals mx plus b. I don't know if you can solve it on paper, or you can unmute your mic and tell us what to do. It's fine. If you don't get it, I can go over it. So basically you have this equation right here. And basically you have to make the y on one side. So this y have to be alone, and it cannot be two y. It has to be one y by itself on one side, and the other side has all these variables on the other side. So for this equation, I would basically turn this y onto the other side and make this 16 go on the other side. So it basically will be like 3x plus 16 equals 2y. And you want to isolate the y to be by itself, not 2y, but 1y. Then you would divide it by 2, which you get 3/2x plus 8 equals y. That's how you would turn it into a slope-intercept form. And also for I don't know if you want to try this one, or you still want me to go over it. You can type it in the chat if you want me to go over, or like you want to try it out. That's sure. I can do it. And so basically for this, you also want to isolate this y on one side. So you want the x and just the integer by on the other side. Y has to be on one side by itself. So for this case, I would move this y here and move this 12 here. So it becomes 13x plus 12 equals 11x, oh no, 11y, my bad. Then you would divide it by 11 because you want just one y. So it'll become 13 over 11x plus 12 over 11 equals y. Did you get that? And next, we're gonna go to standard form. Okay, so standard form is ax plus by equals c. So it's basically similar to the other one, but different. The standard form of a line is in the form ax plus by equals c, where a and b are non-zero integers and c is integers. So in order to have x and y, you cannot have a or b to be 0, and c can be any number. So c can be 0 too. And that is example of the standard form. 3x minus 2y equals 5. So you see that it says ax plus by, but it also can be 3x ax minus by. It's the same depending on the number, the value of y. Okay, here are some practice problems. I'll go over the first one so you can see how we're doing this. So basically, you want in this case, you want this number to be alone by itself. In the other problem, it was y, but in this case, we want this number to be by itself. So we're gonna move this negative 5y onto this side. So it becomes 8x plus 5y equals 3. That was easy, right? That's how you do this problem. You want to try this one, or I can do it too if you want. You can type it in the chat if you can. Unmute yourself. I guess then I'll go over it. So basically, there is not a number you can see right there, so you don't know what the number is. So we would assume that the number equals 0 because you don't see a number. And basically, you want x and y to be on the same side. So it will become 19x minus y equals 0. Okay, we're gonna go on the other side. Okay, it's the last formula we have, which is parentheses x minus x1 equals m times parentheses y minus y1. In this case, x1 and y1 are the actual numbers from the line you have, and x and y, they are just variables. But x1, y1 would become number when you're trying to plug them in or solve them. And m is the slope of the line. Okay, I'll go over these. So Basically, you use the formula x minus x1, which in this case is -2, equals m, which is 9, times y minus y1, which in this case y1 is -3. And you would plug them in. That's easy. You would just plug them in, which becomes x minus, it would be minus -2, so it becomes +2 equals 9 times y minus 3. For this problem, it will be x1 would be 4, y1 would be 0, and the slope would be -7, so it would be x minus 4 equals -7 times y, because y1 is 0, so it would be just y. And for next one, we have solving linear systems, which is solving two linear equations together, try to get x and y. So first one, we have substitution method, which is in one of the equations, isolate one of the variables, replace it in the other equation with whatever you found by isolating it. Okay, so here is an example. So basically, you see that here they have isolated the x. So in this equation, they plugged in this 5 minus y into the x, which becomes here. So in this equation, you only have y as the variable, which is easier to solve, and you can get that y equals -1. And then you have these two equations. You can plug the -1 back into any equation for y, so you can get that x is equal to 6. And we have another method, which is elimination. So elimination method eliminates one of the variables by adding the two equations. In this way, you eliminate one variable, so you can solve for the other variable, which is kind of similar to the other one as well, because both of them uses only one variable to solve. And here is the example. So basically in this case, they eliminated the x, so only y is left, which in this case, you divide it by both sides by 7, so you get y plus 0 equals 1, which means y equals 1. Okay, so here are 3 different types of solutions you can get from a linear system. So do you know any of these? Do you know any of these like are called? Okay, so I'll go over it. The first one is called intersection, which means that there's only one solution, which is this part. So this coordinate right here would be the solution. For example, I think it's around 2.3 and 2.1. So that pair would be the solution for this graph. And then for the next one, we have parallel, which means there's no solution because they're not intersecting at all, so you cannot find a solution. And for the third one, it's infinite solutions because both of the lines are they're on the same line, both of them. So that means that they're intersecting at like they're at every point they're intersecting. That means that there will be infinite solutions that we can find. So every point on this line would be a solution. And here are some practice problems. I'll go over it since I don't think I can show example. So in this case, we already have y isolated for us. So that means that you can plug this y into this y. So it would be easier for us, which will have x as the only variable in this case. So when I plug it in, it will become negative 3x minus 2, and y in this case becomes this, which is 5x minus 7 equals negative 12. Then you will solve it, so it becomes negative 3x minus 10x, because you distribute this negative 2 into 5x and negative 7. And negative 2 times negative 7 would become positive 14 equals negative 12. And negative 3x minus negative 10 would be negative 13 plus 14 equals negative x equals negative 12. So you would isolate the negative 13x, so you would minus 14 on both sides, which becomes negative 13x equals negative 26. You would divide both sides by negative 13, becomes x equals 2. And you know that x equals 2, you would plug it back into this equation, or either one, but this either equation works, but this, in this case, y equals 5x minus 7 would be easier. So it would be 5 times 2, which is x, minus 7. So y would be 3. And in this case, I'll also, do you want to do the second one, or I can go over it as well? I'll go over the second one, which would be, I would isolate the, I think I would isolate the x in this case. So it would be 6 minus 20, 6y minus 20 equals 4x. So x would be 6 over 4y minus 5. I will plug this into the x here. So it will be negative 4y plus 3 times 6 over 4y minus 5. Sorry, my handwriting is so bad, but equals negative 12. Negative 4y plus. So you distribute 3 to 6 over 4y and negative 15, so negative 5, so it would be 18 over 4y minus 15 equals negative 12, which you would combine the like terms. Did he left the room, or is it connection problems?
Yeah, I did.
Okay, we're just gonna go over it anyway because it's her recording.
Okay.
So it would be, you add the like terms, which would become 34 over 4y. Did I do it wrong? Why do I feel like I did it wrong? It's like a, it becomes 3. Did I do it wrong? I feel like something's wrong here.
I'll do it too.
Or was I supposed to do the elimination process? But I can't do elimination here.
Or you could multiply the bottom one by like -1, so like the 4y will become positive. Wait, no. Oh, that's a 4x and 4y.
Oh, I think I'm gonna clear this. I think you can do this. So basically you do this together. So it becomes 2y equal, oh no, 2y minus x equals a. So that you get the x equals, right? X equals 2y minus a equals x, and you plug them in to this, any equation works fine, I think. So it'd be 6y minus 4 2y minus a equals 20. 6y minus 8y plus 32 equals 20, which means 14y equals 52. Oh, I got it. So y equals 3.
Yeah.
No. Oh, I did it wrong. It was it's supposed to be 2y, negative 2y, negative 2y equals negative 12. Then you divide it by 12, negative 2. So y equals 6. Okay, that's how it works. And then you plug it into, I don't know, this equation again. So 6 times 6 minus 4, x equals 20. 36 minus 4, x equals 20, so x equals 4. Okay, I think that's all. Okay, we're running out of time, I think. We're a little bit slow. Yeah, I was supposed to do elimination for the second one. Okay, we're gonna go into transformation now.
So translations are a type of transformation that glides all points of the plane the same distance in the same direction. So this is a notation for translations. And as you can see in this picture, like we want to move all the points 1 unit to the right and 5 units down. So for the point R, as you can see, you have to add 1 to the -2, which will become -1. And for the Y coordinate, you have to minus 5, which you will get -1. And you do the same for the rest, and you will get 2, -4 for coordinate U, and -3, -5 for coordinate Y. So let's do some practice problems together. For Z, the coordinates are 0, 3. For P, the coordinates are -5, 1. Coordinate N is -4, -1. And for Q, it's 0, -2. And so in here, you need to move all the X 4 units to the right and all the Y's 2 units down. So Z will become 4, 1. P will become -1, -1. N will become 0, -3. And Q will become 4, -4. So now you can plot all these points, the new points, onto the coordinate plane. So let me just do that. Yeah, so it will look like that. Now for the next question, you do the same thing. For E, the points are 4, 4. For P, it's 3, 2. And for B, it's 5, 0. Now this time you have to move it 5 units to the left, so -5, and 2 units down, so -2. The new coordinates of E will be -1, 2. The new coordinate of P will be -2, 0. And the new coordinate of B will be 0, -2. And again, you just need to plot these points on a coordinate grid, and that's how you do translations. Next slide, please. So now we have line reflection. This is a type of transformation in which a figure is reflected or flipped over a given line. Notation. This is a notation. The line reflection depends on like what line it will be. So if it's like reflected over the x-axis, you just have to negate the y, which will be -4. And the line of a reflection is perpendicular to the perpendicular bisector. So depending on what line is reflected over, the notations will be different. So for example, if it's reflected over the x-axis, you have to negate the y value. If it's reflected over the y-axis, you have to negate the x value. If it's reflected over the line x, y equals x, then you have to switch the two values. And if it's reflected over the line negative x, then you have to switch the positions and then negate both values. And this is an example of a reflection over the y-axis. So let's do some problems together. For this point, it's 0, 1. And for this point over here, it's -2, 4. And last point over here is 3, -4. Now this is reflected over the line y equals x. And as you can remember from the previous slide, when you reflect the line over y equals x, you have to switch the positions. So it will be y, x. So you just have to switch it.
Wait, I think the last one should be -4, 3.
Oh, sorry. So yeah, so you just switch the x and y values. This will be 4, -2. And the last one will be 3, -4. And for this question, over here, you have to reflect over the y-axis. When we reflect over the y-axis, you just have to negate the x values. So the first point over here is 0, 1. The second point over here is 1, 4. And the last point over here is 5, 1. And now you just have to negate all the x values. Since 0, you negate it, it's still 0, so this point will be the same. And this point will be -1, 4, and the last one will be -5, 1. Rotation. Rotation, it turns a figure through an angle about a fixed point called the center. The positive angle of a rotation turns a figure counterclockwise. The negative angle of a rotation turns a figure clockwise. Rotation, that's the notation for rotation. It's r degrees and then x, y. As you can see, if you rotate 90 degrees, you have to switch the values and negate the y, the first one. When you rotate 180 degrees, you have to negate both x and y. When you do a rotation for 270 degrees, you have to switch the positions and then you negate the x value over here. And for a rotation of 360, you just stay the same because of 360 degrees is a full circle. So you return to the place that you are. And for negative degrees, it's like going backwards. So if you start over here going negative 90 degrees, you're gonna go over here, which is 270 degrees. Next slide, please. Yeah, so here's a picture of a rotation of 90 degrees. Now let's again, we need to find the points first, all the points first. So the first point over here is 1, 2. The second point over here is 1, 5. And the third point over here is 3, 2. And the last point over here is 3, 4. And now we have to do a rotation of 180 degrees. When you do a rotation of 180 degrees, you have to negate both x and y value. So this will be -1, -2. This will be -1, -5. This will be -3, -2. And this coordinate will be -3, -4. Now let's go to the second problem. And this time we have to do a rotation of 90 degrees about the origin. So again, we have to find the coordinates. This point is 2, 3. This point is 2, 5. And the last point over here is 4, -2. And when you do a rotation of 90 degrees, you have to switch the place of x and y, and they have to negate the y value. So this will be -3, 2. This will be -5, 2. And this one will be 2, 4. And for the last transformation, it's called dilation. A dilation is a transformation that produces an image that is the same shape as the original, but it's in different sizes. So that's the notation for dilation. You just times it by the scale factor. Again, we're gonna find all the points over here. So for this point, it's 4, -3. For this point here, it's 2, 2. And lastly, for this point, it's -5, 2. And now we have to dilate it by a scale factor of 1/2. So you have to divide all the values by 1/2, which will be 2, -1.5. This will be 1, 1. And this will be -2.5, 1. Now for the second question, this time we have to dilate by scale factor of 2. So let's find the coordinates of all the points first. So for this point over here, it's 5, -5. For this point here, it's -5, 4. And for this point here, it's -4, 0. So this time you have to dilate it by a scale factor of 2, so you have to times everything by 2. So this will be 10, -10. This will be -10, 8. And this will be -8, 0. Next slide, please. And now we're gonna go over rigid motions. A translation that preserves distance. The image is congruent to all that of the pre-image. So examples of transformations that preserve distance are translations, line reflections, glide reflections, point reflections, and rotations. Direct, how do you say this? Wait.
I think it's isometry.
Isometry. So direct isometry is when you have the orientation is preserved. So like in translation, all the orientation is preserved. Like if you have a triangle of A, B, C, and after you transform it over the coordinate grid, it will stay the same as A, B, C. But opposite isometry, the orientations is not preserved. So like that happens during like a reflection. So when a triangle is like A, B, C, when it's reflected over here, the orientation might change. So it'd be like C, B, and then A. Next slide, please. And that's the end. Thanks for coming.